Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787-900 United flight from Zurich International Airport. We can be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize our landing. So I'm in the cockpit for the takeoff preparation of the Quality Wings and Microsoft Flight Simulator X Boeing 787-900. The aircraft I'm gonna start showing in the cockpit instruments, the displays and the functions of the Boeing 787-900. The aircraft is gonna start with the primary flight display. The displays the airspeed indicated, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the magnetic heading and track, the magnetic north pole and true north pole magnetic variation depending where we are in the world. We have the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climate descent of the aircraft in tens, hundreds, and thousands of feet per minute, or the steepness of the trigonometric angles in decreasing and climate descent. We have also the navigation display. Also, we have the artificial in the primary flight display. We have the artificial horizon with the added indicator, the pitch ladder in degrees and the bank angle in degrees, the horizontal localizer and the vertical glide slope of the Lszh localizer, the instrument lighting system that guides the aircraft horizontally and vertically in the runway for landing. We have also the Lszh localizer, the frequency and the name display. We have the Lszh localizer crossbars. We have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the flight mode annunciator with the autopilot and the auto throttle later on vertical navigation modes and the flight and the angle of attack of the aircraft as it flies. So we have also the navigation display. The navigation display that displays the terrain map, the terrain and weather reflections from the weather radar. You can see the terrain around you in a horizontal and vertical profile. Also, you can see the flight plan of the aircraft that we have already created using the flight management computer in a horizontal and vertical profile. You can see the terrain map. You can see the airports, the waypoints that are horizontal and vertical navigation fixes the aircraft has to fly through. Also included, you can see them in the navigation display. You can see the distance. All these things are located, the force stations, the ADFs, the MDBs. We have the magnetic north pole and true north pole magnetic variation again, depending on where we are in the world. We have the next waypoint we have to be overflying. We have also the wind direction and speed. Also, we have other aircraft that fly around our own aircraft displayed using the transponder, the DSP and ADC transmitter receiver that transmits our own frequency to other aircraft and receives and also transmits to air traffic control, so it receives from other aircraft and generates the diamond shape, the warning you can see in the navigation display, the other aircraft movement, where they are located, the distance, the altitude they fly, the altitude difference from our aircraft, whether they climb or descend, and also this calculates the airspeed of the other aircraft and our own airspeed using the frequency of the transponder and generates the warning of the TCAS system, traffic collision and advisory system. We have also the autopilot and flight director system panel, the FDS. I will explain later. So in the navigation display also we have, you can see the flight plan I have just created here. Using the flight management computer, you can see the horizontal and vertical, this Mazda line here. So you can see the vertical profile we have to follow and the horizontal. In the terrain map, you can see also the airport, the runway we're gonna use for takeoff, and the climb we're gonna have. Also, you can see the primary flight display, the airspeed, the altitude. So I will make the whole explanations of the cockpit. So we use the flight management computer. Over here you see we have this. So I created the flight management computer, the flight plan, using the departure and arrival. I will explain you now. So we have the aircraft, we have the takeoff gross weight of the aircraft that includes the empty weight plus the passenger plus the cargo plus the fuel on board, the trip fuel, the reserve fuel and the tax fuel. We have where this fuel is stored. We have the left and the right wing tank, the center tank, and the flight management computer will gonna calculate when we input this data the center of gravity of the aircraft, also the main aerodynamic chord position, the Mach, which is a percentage of the forward wings of the aircraft, about 23% of the Mach, or about um, it's the position with the maximum aerodynamic lift occurs in the forward wings. It's also the position where the center of pressure occurs in the top surface, using the airflow of the air mass, using the Bernoulli theory of fluids and Newton's physics, so and aerodynamics. So we have also is the position where the stall begins. The aircraft, the airflow around above the wings of the aircraft start becomes detached from the top surface of the wing. So the center of pressure, the center of we have also the center of gravity around the same position where the aerodynamic chord is, and this is calculated automatically using this computer every time when we input the gross weight of the aircraft for takeoff. Also the flaps we use for takeoff around 15 degrees for this flight, and this also will calculate the center of gravity and the longitudinal axis, also the transverses, the center of gravity and the lateral axis. We have the horizontal tail trim stabilizer position, so we can trim the horizontal tail of the aircraft during the whole flight from takeoff, climb, cruise, descent, approach, and landing. I will show you we do that either manually using the trim switch in the control wheel, or automatically using the autopilot and flight director system panel that has the auto trim function. So you can see here so here is the mean aerodynamic chord of the forward wings. About 23% of the chord of the wings is the position where the center of gravity usually transverses the aircraft. We have the lateral axis from wingtip to wingtip, the longitudinal from the nose to the tail, and the vertical that transverses the center of gravity. Also the vector from the engines, the thrust that propels the aircraft forward, and the horizontal trim stabilizer is gonna balance all these things in flight, so we have to trim it or use the elevator to climb and descend to balance the aircraft in flight. So we're gonna use the horizontal trim stabilizer all the time. The elevator, also the rudder, the vertical stabilizer. I'm gonna show you the flight controls later. So you can see the horizontal trim stabilizer here, this trim switch we use to trim the horizontal tail of the aircraft up and down all the time. And here we have the cutout trim. If we have a failure of the hydraulic of the L2 or the R2, we have to disconnect the auto trim from normal to cutout, pulling up this guarded switch like this. So you see the cutoff. We have also the alternate pitch trim here. So you have a failure of the auto trim of the autopilot and flight director system panel because of this the hydraulic of the L2 and the R2. You disconnect from this. So you have only the manual trim from the tail over here. So after that I'm gonna show you so we input all the data of the aircraft for this flight. That includes the takeoff gross weight, the flap settings for takeoff. This will calculate the mean aerodynamic chord position to 3% of the Mach of the forward wings, and the horizontal trim stabilizer for takeoff is gonna be 4.25 degrees pitch up. So this will be calculated every time using the flight management computer. We input the runway we're gonna use for takeoff, the Zurich International 114, the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density and the temperature of the air, and also the runway conditions if we decide to dry or wet. And we have the takeoff speeds, the V1, V rotate, and the V2, which is the initial climb speed after takeoff. So you can see here, so the initial climb speed after takeoff. We're gonna have also, just so you created the flight plan using the flight management computer. I input all the data of the aircraft, the departure runway, that includes also the seats, the other instrument departures and runway waypoints and fixes. That include horizontal and vertical waypoints and fixes for the initial climb, and altitude and airspeed constraints. So so you can see also altitude constraints. Then we have the top of glide to the cruise level, the remaining waypoints and fixes, then the top of descent, and the stars, the southern terminal arrival and waypoints. After the descent, we have the approach, the long final and the short final approach, horizontal, vertical navigation fixes, and altitude and airspeed constraints. Is gonna align us with the runway 14 in the Zurich International Airport. This is the destination airport. When we set the route using the flight management computer again automatically, we have the flight plan from takeoff, climb, cruise, descent, approach, and landing, which can be used also by the autopilot, the flight director system panel, to fly the aircraft automatically if we don't want to fly manually. So you can see all these things here happening. We have also using the stars as other terminal arrivals, waypoints and fixes. We have the Lszh localizer of the destination airport runway. We have the magnetic North Pole heading is going to be tuned in the autopilot and flight director system panel in the heading guidance. So the aircraft is going to be aligned with the magnetic heading of the runway during takeoff and landing. And also the Lszh localizer is going to be tuned automatically using the flight management computer. The frequency of this is going to guide us, is going to send the signal, it's going to receive the aircraft and align with the horizontal localizer and the vertical glide slope, the vertical profile glide slope. So it's going to be aligned with the runway magnetic heading, and Lszh localizer heading is the same. Also we have the crossbars of the Lszh localizer purpose. Landing the runway using over here gonna be either, so I'm gonna do this manually again one more time, manual landing. So you're gonna see later in the complete flight from takeoff, climb, cruise, descent, approach and landing, we're gonna have a complete flight in the end part of the video, like every time. After explaining all the systems, making the engine start demonstration. So you're gonna see how we're gonna use the Lszh localizer, the instrument landing system of the aircraft, of the airport, and then the aircraft systems in the primary flight display. So we have also, after this, I'm gonna show you the autopilot and flight director system panel, the autopilot engage and disengage switch, the auto throttle left and auto throttle right, engage and disengage switch, the airspeed select knob. You can select an airspeed, nautical miles, knots, or Mach speed, and select the modes like flight level change, climb, continuous auto throttle with the speed mode, and the flight director on and off. We have also the VLNAV and the VNAV using the flight management computer input. The autopilot can follow the flight plan we have created horizontally and vertically, or either. I'm gonna show you also that. So we have also the heading guidance, the vertical rate of climb, descent of the aircraft, and 100,000 feet per minute of the signal, so the chronometric angles in degrees can climb the descent. Also the altitude select knob and the altitude hold switch, the board localizer switch, and also the airspeed utilizes, as you know, the thrust produced from the engines. So it commands the engines. You command the engine's thrust rating when you select the airspeed guidance from the autopilot flight director system panel. You give a command to the engines. We have the GNX engines installed in our aircraft, one in the left wing, one in the right wing, for symmetrical thrust and redundancy, which are turbofan towards the engine. So each one contains a gearbox with the FADEX. The FADEX are the full authorities electronic control computers, one installed per engine gearbox. Dual channel redundancy, one channel faces the other, takes over, controls, monitors and displays all the functions of the engine. You see in the upper and the lower ACAS engine indication and crawler system display of the multifunction display. So you can see the N1, which is the low speed starter, sub low pressure compressor and turbine of the turbofan which is engine. The exhaust gas temperature per engine, the N2, which is the high speed starter, sub the high pressure compressor and turbine of the turbofan which is engine. The outflow air, the pressurizer from the 5th and 9th stages of the turbofan engine, which is used for hydraulic fluid pressurization, for the hydraulic fluid tanks pressurization, wing and engine AVIs, air conditioning and ventilation, and also for cabin pressurization. We have also the reverse flow from the APU into the engine. When we start the engine, we have the engine start process, so we're gonna start a small auxiliary power unit, the APU of the aircraft, which is gonna provide us with alternate current. I'm gonna show you right now how I'm gonna start the switch and make the engine start demonstration later. We're gonna shut down the engines and restart them. So you need in the process of restart, we need the pressurizer from the APU to pressurize the engine starter. Also we need alternate current, direct current also. So you can see also here we have the APU here in the electrical. I'm gonna show you later the overhead panel. So you can see the electrical here, the battery, the APU generator battery, the left and the right engine ITZ, the great drive generator, 120 to 100 volts, 400 Hz alternate current frequency. Also 28 volts, 48 from the batteries and the APU. We need to start the primary flight control computers, the heading reference, the flight control computers. We have the window heat and the passenger oxygen, the hydraulics, left and right, I'm gonna show you later, and the fuel system, the fuel on board, left and right, wing, the cabin pressurization and the pressurizer from left and right engine. So you see all the systems, also the engines, systems and system display on other systems. I'm gonna show you later in the display. So we have as I told you the N1, the N2, which is the high speed starter, have the high pressure compressor turbine of the turbofan with this engine. The fuel flow per engine per hour, 1000 kilograms or 1000 pounds, oil pressure, oil temperature, oil quantity, the vibration of the N2 stage of the engine. Also we have so we have also the FADEX controls the engine start, engine shut down, the fuel heat exchange sensors, the fuel metering unit, the fuel, the oil heat exchange sensors, the pressure inside the engine sensors, also the fuel mixture. So as we climb and descend the aircraft into higher or lower altitudes, we have a difference of temperature of the air, of the oxygen level, of the density of the air. Also the aircraft can fly in a higher or lower airspeed as we climb and descend. And this σε 40 λεπτά θα το έχω κάνει. Και μετά θα πάω σε 40 λεπτά θα το κάνω. Θα το κάνω σε 40 λεπτά. 40 λεπτά θα το αρχίσω. So we have also so we have all the systems. We have the fuel as we climb and descend. So the FADEX control the fuel mixer as we climb and descend the aircraft into higher and lower altitudes. Instead of doing this manually as you do in turboprop aircrafts. So I'm gonna show you also. So this will command the engine's thrust here. So you move the thrust forward and up manually like this. and we'll command the FATX again. So you can disconnect anytime the autopilot and flight director system. So I'm gonna show you now the flight controls of the aircraft using the side stick here. So we have the flight controls control using the side stick. We control the horizontal tail of the aircraft for climb descent using the control column, pitch up and pitch down. Also bank rolls left and bank rolls right. Using the control wheel. Also we have the rudder pedals. We can use the vertical rudder for making your own turns left and right. Also we have the rudder pedals for toe brakes and for nozzle steering in the ground. So we have here also, you can see the flaps here, extend and retract. We can have also the fuel flow for the left and the right engine, the auto throttle disconnect. You press this switch and you disconnect the auto throttle over here. We have also, as I told you, the horizontal trim stabilizer, the cutout switch, the display. The alternate pitch stream and the parking brakes. Also you can see the display of the flaps over here. The landing gear extend and retract, and the alternate gear, the lock override. So you have the display here, the N1, which is the low speed starter, the low pressure compressor, turbine of the turbofan positioning, the takeoff, the maximum takeoff 100.80%, the exhaust gas temperature ranging, the N2, which is the high speed starter, the high pressure compressor, turbine of the turbofan positioning, left and right. The fuel flow range per hour 1000 kilograms or 1000 pounds, so the pressure, temperature, quantity, and the vibration of the N2 stage of the engine. So we have also the displays here, the primary flight display, the airspeed indicator, the barometric altitude, the altitude selected. So we're gonna change the values. We have also the takeoff ground, the flight director, the pitch ladder, 2.5 degrees, 5, 7.5, 10, 12.5, 15, 17.5, and 30 degrees, pitch up and pitch down. We have also the vertical rate of climb descent. This needle you see is moving up when we climb and it's moving down when we descend. So we have the auto throttle, so you can see here the flight director on and off. So we will set the airspeed for the takeoff over here, and after that we're gonna make the engine start demonstration. We have also the bank angle limit here set. So we'll set it in the climb rate like this. Over here you can see all the switches function. So we'll set this like this for the climb rate, and I'm gonna show you now the flight controls, then the overhead panel. Make the engine start demonstration. So the flight controls of the aircraft, I have this side stick to control, as I told you, the horizontal tail up and down using the control column, and also the ailerons and the spoilers to make bank rolls left and right, and the rudder pedals to make the yawing turns, the nose wheel steering, and the toe brakes. So we have all the controls of the aircraft from takeoff, climb, cruise, descent, approach, and landing. Also the horizontal trim stabilizer and the engine thrust are produced using the sliders. So I'll show you now the flight controls. Also the outside view of using the flight controls. You'll see the aircraft tail moving up and down and around, and the ailerons in the spoiler. So we have it here. You can see so we have the climb and descent here. You can see the side stick movement. So you can climb and descend, and you can make also barn rolls left and barn rolls right. Also use the horizontal trim stabilizer, and use also the thrust levers over here. So you can climb the aircraft, make turns to the left, make turns to the right. So you can see we can use all the flight controls together, like in the hands-on throttle sticks, the Hatsios system. The fighter jets, also the horizontal trim here. So you can see the engine thrust here a little. Is moving up here, this point up and then down. So we have all the controls now. You can see the side stick deflection is proportional to the yoke deflection. Also both sides are interconnected to the captain and the first officer, move together. So we have full control. Also we can leave neutral. Also the outside now view. I'm gonna show you a little bit the outside. So you can see we can climb, we can descend. So we can climb, we can descend, we can make turns to the left and turns to the right. So this is the full control of the flight controls of the aircraft. It's like any regular aircraft, as you can see, either Boeing or Airbus or Embraer or CRJ or Canadair. So we have here again the displays. Also now the overhead panel, we're gonna make all the systems display, the engine start demonstration, then the displays of the primary flight display and the navigation display. So we make the engine start demonstration. Thank you for staying with me until now. I'm Thomas Hatsios, the German American pilot flying the Boeing 787 900. So you're gonna see the complete flight from takeoff, climb, cruise, descent, approach, and landing in the end part of the video. So we have here. So you can see we can use this for this system for starting the engines. So we turn on the APU. We have the left and right engine, the IDG as I told you, the hydraulics here. You can see we turn off a hydraulic. The fault will blink here. So we reset back to the on. Also the other side, the right engine driving hydraulics. If we set them to the off, you will see the fault here. Also we can see in the displays. So we have the rammer turbine also, flight control computers, heading reference, flight controls, electronic engine control for the engines left and right. I'm gonna show you later the auto start. We can dump some fuel in flight. We have the left and right wing fuel tanks. The crossfeed also, which is off right now, and we can turn on. The wing and engine on the ice. The cabin pressurization here, so you can admit some pressurizer, and also use the manual mode. You use the outflow valves when you climb and descend in the manual. So we have the auto, so you have to select the landing altitude. So this is the pressurizer from the left to the right engine. The APU also, we need to restart the engines, and we have all the systems, also the fire extinguishers, APU and cargo. Also here we have, as it was, fuel control left and right engine, auto throttle disconnect, and left and right engine fire extinguishers, also transporter, rudder trim. So this is all the systems explained. I will show you only a small bit of information here about the systems. You can see the hydraulics, the APU is running, the oxygen and the liquid cooling also. We have the electrical left and right engine. You can see the APU, the voltage here. So you can see the drive is connected. You can disconnect the drive also. So you see the battery's voltage, charge and discharge, and you can see it's the same diagram you see here about the electric. So we have also the hydraulics. You can see the left and the right engine hydraulics, the C1 and C2, which is also air pressurized, the quantity of the hydraulic fluid and the pressure of 35,000 psi. You have also some sort of valves, the electric. So we can use that. Hydraulics, you see the diagram, the fuel here, and the pressurizer, which is the main component. Have also the flight controls. So you have the left and right wing, how much fuel you have in the left and right wing, the center tank, also total fuel board, low and high pressure fuel valves to the left and the right engine. The APU is fed from the left wing using the DC motor. The crossfeed is off, but if you open it, you can feed either engine with either tank or either pump. You can also balance the fuel between the left and the right wing. And you can see here the minimum fuel temperature below which the fuel will freeze in flight. So we have the air also, the pressurizer, the temperature, left and right engine, the doors are closed, the cabin can be pressurized, the landing gear, you can see the temperature of the brakes and the pressure of the tires, the flight controls. So you can move the flight controls like this and make turns left and right. Also the rudder pedals. So you see all the flight controls are fully moving. The FS display, the maintenance, the circuit breakers, the checklist. You can see the checklist here, just like in the Boeing 777, the resets. So you have what you need to do if you have also failure of a system. You can see some touch screen also, the communications, the navigation display. So now we go for the engine start demonstration. So we sat down, so we need also this lighting here. We need to shut down both engines. So fuel control left and right engine to the off. You will see both engines shut down, the right and the left. So we can see the N1 and the exhaust gas temperature, the messages. We have the engines shut down now. So you can see no engines right now. We need to restart over here both auto start to the on. So we're gonna have pressurizer admitted. The N2 stage when it's gonna be above 20%. Over here we can admit the fuel, so we let the fuel flow here both on, and we have the auto start is on over here. As you can see, auto start. You can see auto start left and right engine. Also the parameters are correct. So you can see the messages are going off right now, and we have both engines to the run, both running. So both engines now running, and we can go for the flight. So flaps up, parking brakes off. And we advance the thrust levers. So we taxi into the runway, we take out the air traffic control clearance. The runway is on for us. So we align with the runway. So here is where we are and where we're going, and we have about a few more minutes for this flight. So we need to have the view for the takeoff. So we advance the thrust levers, flight director off, parking brakes off, and we go. Have maximum takeoff power right now, and we align now with the rudder pedals again. As you can see, rudder pedals for align with the center line, and we have V1, we rotate, and V2. So we keep climbing, positive rate of climb, landing gear up. So we are about 800 feet above the ground, the airspeed, the altitude. So reconnect this, and we are about 2,200, 300, 400 feet, the airspeed 2,400 above the ground, 4,000 above the sea, with climb 4,000, 5,700 feet per minute, the airspeed target and the altitude target, also the stall speed here below the airspeed, and the pitch attitude here. We need to lower the pitch attitude and the flight plan. You can see also the terrain below us over here. The altitude, we are flying here above the ground, and the horizontal flight plan also. You can have some data here. So you can see where we are, and we are departing. So we need to climb now. And also we need to make the turn now. So we keep climbing. As you can see, we also need to follow the flight plan here. So we're gonna make a couple of turns, and you're gonna see the lines we have to follow. We need to make a turn like this. So you see the outside view of the aircraft. We are flying Switzerland, my homeland Germany. Also in front of you in the France, in this side. So we have the star sign, beautiful star sign, with the galaxy here. So you can see also the beautiful lake. So we're gonna have also to follow the flight plan now. So following back the flight plan, have to be in the track. So you're gonna have to follow the horizontal and the vertical. Over here you see the horizontal, the flight path this line of the flight plan we created. So we need to pitch stream also, you can see. I'm flying like this on Lszh here now. So here we are very close to the lake, and we have another aircraft also flying closer to us. Beautiful views. The galaxy and the Switzerland, the Germany, the Bayern Munich. In front of you, the France. So the whole of Switzerland here, and the aircraft Boeing 787. We're flying with about 400, about 500 kilometers an hour right now. Or max 0.4. So keep climbing. So we level off for a while here, with 25,000 as you can see. So we can also increase the airspeed like that. And we keep climbing. Overflying out the lake. Here the Germany, the Bayern Munich and the France. And we have the beautiful star sign over here. We're gonna have also the chemtrails in a while. And level off for a while. You can choose the engine thrust rating here, the autopilot settings. So it's 27,000. And we have the chemtrails now and the contrails. As you can see, we have the frozen vapors, and we overflying the Germany here and the Switzerland and the France, and we have. So we're going back now to the airport. We need to start the turn now. To the airport turn over here. So we need to level off here as we make the turn. So make a fast turn, overflying the lake, the beautiful lake, and the Germany, the Bayern Munich, and the France and the Switzerland, with the beautiful lakes here. So we fly now with almost 500, 600 kilometers an hour with the Boeing 787-900. Over here we need to increase also the airspeed, as we're gonna see. So we need to go back for the flight one. Over here, make so we're flying manually now. Over here, as you can see, we're flying manually. And we make a shortcut for the flight. Over here, we're flying manually, as you can see. So you can see the flight here. We have the chemtrails or the contrails, chemtrails from the aircraft. We are flying Germany and France, and we have the star sign here, the galaxy. Beautiful galactic view from the aircraft, and now the Switzerland, the lakes over here. So we're gonna be flying with 900 kilometers an hour in a couple of minutes. So we retract the flaps and we increase the airspeed. So you can see we follow the flight plan here and here, and the vertical and the horizontal, and here we have the airspeed and the altitude and the rate of climb. You can see all the indications. So we need to hold here. So we are 39,900. So this is the beautiful galactic view of the 787. And we're flying with almost 900 kilometers an hour, 300 meters per second over here. So we need to level off. Now I'm flying manually, as you can see, using my own controls. So we also can connect the autopilot now for display. And we have like maybe 10 more minutes for the flight to return back to the airport. As you can see, now we are with the autopilot flying. So this is the autopilot flying now the aircraft, and we start cruising back to the airport. Also we start the descent, so you can see the airspeed now is Mach 0.779 or 315, 320 almost. And we start the descent. Now we need to fix the descent, the flight path here. So this is 900 kilometers an hour, 300 meters per second, using the Boeing 787. We start the descent here. So we initiate the descent now. and we have to follow through these lines here as we are descending. So we keep descending, start descending here, as you can see. So we need to disengage the autopilot now. We keep the descent manually. So we keep descending. We can increase the rate of descent. And also slow down the aircraft as they are descending. $16,000 feet. Keep descending. So we need to go here for the approach. We need to align now. Let's use that. So keep descending and having the approach in front of you. So you can see the airspeed, the altitude, the rate of descent here, how fast we descend the aircraft right now, and the horizontal and the vertical profile of the aircraft. So we need to align like this now, no problem, flying through these clouds. So we are 5,000 feet. We need to pull up. Also, if you look outside where we are, closer to the runway now. So we're gonna have the landing view and some more flags over here for the descent. So add a little bit more thrust. And we are for the final approach and landing now. Very close. We have the Lszh localizer here. As you can see, all the information, we are 2000 feet above the ground, the altitude 3000 feet above the sea, the rate of descent, we are aligned with the runway, and we have also the terrain below us, the vertical profile and the airspeed. So this is how we align with using the Lszh localizer. A little bit more offline, use a little bit more. So we need to align the combat the side wind here, the component of the side wind. Add some thrust manually if we need. So we need to align having side wind, flight controls, rudder pedals, and yoke and rudder. Also now we have the flare, we need to align and also flare with the runway. Level off now. So touchdown, beautiful, beautiful, beautiful touchdown. As you can see, parking brakes and full reverse idle thrust, full reverse thrust, and align with the rudder pedals again with the center line, as you can see. So we have this beautiful touchdown, fully aligned with the Boeing 787. This is where we are. We have a long time also to go. So we just made it to the runway. You can see information here displayed. You can see we are in the ground, the altitude. So the systems, and we have some time to go, a few more minutes inside the cockpit. So you can see we have the nose wheel here is perfectly safe. There is no breakouts. Also the landing gear behind it, both the left and right. The landing gear, you can see the wheels here. There is no breakouts and no breakouts of the wheels on this side, or the strut as they call it. The metal parts, you can see all metal parts of the landing gear. The aircraft is starting up the way it should be. Also the nose wheel here, the strut, and the tires, as you can see. So we made a nice body, very successful. You can see how. So you can see maybe better. You can see here there is no breakers, it's perfectly safe. Touching for the nose wheel and all the parts. So we can use it for another flight, I know, so we can taxi maybe into the runway. Also, Hatsios Thomas has you flying the Boeing 787-900 model into nice flight over flying Switzerland, Germany, France. Thank you for joining me. I'll see you next flight. Bye bye. We just made a very beautiful landing. Bye bye. Maybe we can taxi also. So we're taxing outside. Maybe you can see better here.